Have you ever found yourself staring at your computer screen and just thinking, there's got to be more to it than this, right? What if, like, your digital stuff could just burst out of that flat screen and, I don't know, mix right into the room you're in? Well, today, that's exactly what we're doing a deep dive on. This fascinating and, yeah, fast-moving world of spatial computing. And for this journey, we're drawing on some really great insights from beyond the screen, spatial computing in everyday life. It's a resource that honestly cuts through a lot of the hype, gives you a clear picture.
Yeah, and our mission today, it's pretty straightforward. We want to break down what spatial computing actually means for you, how it works its magic, behind the scenes, where you're going to start seeing it pop up in daily life, and what cool stuff is just over the horizon. We really want to give you that solid understanding, but without, drowning you in jargon.
Exactly. Because this isn't just about, oh, new headsets are coming out or, another wave of gadgets. This feels more fundamental. It's about how we connect with digital information, kind of blurring those lines between what's real and what's, well, digital. It's like the screen, that box we've known forever, maybe isn't the center of the universe anymore. So maybe let's start with a quick look back. For ages, computers meant a rectangle, right? A green, desktop, laptop, phone. You used a mouse, keyboard, or tapped the glass. That was it, the flat screen world.
Right, and spatial computing just completely flips that whole idea. It's when computers actually understand the physical space you're in. They live in it in a way. So instead of a mouse or keyboard, you interact more naturally by reaching out, speaking, just moving around. Think about digital things not trapped behind glass, but anchored right there in your room, on your desk. Could even be on a city street.
Okay, and Apple's been using this term spatial computing a lot, kind of unifying things. But underneath that umbrella, there are these three, let's call them modes: augmented reality, virtual reality, and mixed reality.
Exactly. Let's break those down with some examples, drawing from that source material. First up, augmented reality, AR. This is where you still see your real world, totally clear, but digital info gets layered on top. So picture this. You're in the kitchen, maybe wearing some lightweight AR glasses, and boom, a recipe hologram is floating right over your cutting board. The key thing, you always see your real surroundings. And those digital bits, they're anchored to real stuff. You've probably used basic AR already on your phone, right? Like Pokemon Go or IKEA letting you see virtual furniture in your room. Okay, then there's virtual reality, VR. This one's total immersion, a fully digital world. You slack on a VR headset and suddenly you're not in your office anymore. You're, I don't know, walking through ancient Rome. Your real world view, completely gone, blocked out. VR is amazing for, super immersive games, training simulations, virtual travel, that kind of thing. Controllers are still common, but hand tracking is getting really, really good now too. And finally, mixed reality, MR. Now this is where things get really interesting. It kind of bridges AR and VR. With an MR headset, think Apple Vision Pro cameras on the outside record your surroundings in real time. That live video feed gets streamed to the screens inside the headset. And then virtual objects get blended into that video feed. So imagine a 3D model of the solar system just sitting there on your coffee table, casting realistic shadows, reacting to your room's light. It feels a bit like AR, but it's powered by tech closer to VR headsets. That lets those virtual things interact really convincingly with your actual space. You can even switch between that blended view and full VR pretty seamlessly.
Okay, that makes sense. So Apple calling it spatial computing.
Yeah.
It really does pull all these related ideas together. It's about the device, knowing the space. It's not just a label. It's a whole philosophy for this new kind of computing.
Yeah, it's a bit of a language land grab, you could say. And it really frames how these devices work. Take the Vision Pro. Your apps aren't stuck on a little screen anymore. You could have a web browser floating over your desk, maybe a giant movie screen projected on your wall, or a 3D model right there in the middle of the room. And how you interact, it's remarkably intuitive. You just look at something to select it, basically, and then you do this tiny little pinch with your fingers, almost invisible. That's your click.
Oh.
It's really natural. And these things are evolving fast. Like Vision OS updates are adding spatial widgets, little interactive info panels, and making the digital avatars, the personas, look way more realistic for calls.
That is pretty wild. But okay, for that solar system to actually sit on my real coffee table and, react to the light in my room, the headset must be doing some serious work understanding my surroundings, right?
Yeah.
What's the tech actually doing under the hood?
Oh, absolutely. Huge amount of processing. It starts with perception and mapping, basically how the device sees and makes sense of your space. A core part of this is SLAM.
SLAM.
Yeah, SLAM. Stands for simultaneous localization and mapping. What it means is, as you move, the device is constantly calculating two things at once: where it is in the room and what the room looks like in 3D. It builds this live 3D map, like a digital mesh or blueprint of your environment.
Ah, I know.
And that's why a virtual object can sit on your real desk and stay put. It's anchored to that mesh. And it's getting more sophisticated. Scene reconstruction can build detailed 3D surfaces, allowing for occlusion.
Occlusion, meaning things can hide behind other things.
Yeah, exactly. A digital object can realistically disappear behind your real sofa, for instance. Both Apple's AirKit and Google's AirCore frameworks handle this kind of world understanding. Google's AirCore even has geospatial anchors now, so you can pin virtual stuff to real-world GPS coordinates, like a virtual statue in Times Square that everyone sees in the exact same spot.
That's pretty mind-bending. Okay, so it understands the space. Then how does it make the digital stuff look, real? How does it render the scene?
Good question. For mixed reality, a lot of that comes down to pass-through MR. Those cameras on the outside film your surroundings, right? Then the system digitally composites the virtual objects onto that live video feed before showing it to you. The Meta Quest 3 does this with full-color pass-through now, so your real world looks pretty vibrant inside the headset. The big challenge there is latency. Any delay between your head moving and the image updating. That can make you feel sick fast.
I can imagine.
And another really clever trick is foveated rendering. The headset has eye-tracking sensors inside, and they know precisely where your eyeballs are pointing at any given moment. Okay.
So the system renders that specific spot you're looking at in super sharp high detail. But the areas in your peripheral vision, it renders those at a lower resolution.
Ah, because you wouldn't notice anyway.
Exactly. Your brain fills it in. This saves a ton of processing power and battery, but you still perceive the whole scene as being incredibly sharp. Apple Vision Pro uses this heavily.
And that leads us to another huge shift, doesn't it? Natural input. Getting away from the mouse and keyboard we've used forever.
Precisely. Spatial computing leans into how we naturally interact with the world. Vision Pro, like we said, look to highlight, tiny pinch to click, super minimal. Meta's approach, direct touch, is a bit different. It lets you reach out and tap or swipe on virtual panels directly with your fingers, kind of like a floating touch screen.
Right.
Voice commands are still super useful, of course, especially for accessibility or just being hands-free. And controllers, they're definitely sticking around, especially for gaming.
Yeah.
Oh, and we can't forget biometrics. Vision Pro's Optic ID uses your iris, the colored part of your eye, for authentication.
Like in the movies. Kinda, yeah. Super secure for unlocking the device or making payments. Shows how personal these devices are getting.
Okay, so we've got all these amazing experiences being built on different devices.
Yeah.
How do we stop everything becoming totally fragmented? How do we make sure stuff works across different headsets? It sounds like a job for standards.
It's absolutely critical. And there are two big ones emerging. First, OpenXR from the Kronos Group. Think of it as a universal translator for XR apps. It's a standard API application programming interface that lets developers write their app once, and it can then run on lots of different headsets that support OpenXR. Huge deal for developers.
Saves a lot of redundant work.
Totally. And the second one is OpenUSD. That's Universal Scene Description. It originally came out of Pixar, actually. Now it's backed by giants like Apple, Adobe, NVIDIA, basically everyone. It's a standard way to describe complex 3D scenes models, lighting, textures, animation, everything. It means you can move these incredibly rich 3D worlds between different software tools, like from a modeling program to a game engine without losing all the detail.
Yeah.
Really important for big collaborative projects.
Okay, this is where it gets really practical. Let's talk hardware. What can you actually, maybe even buy or encounter today? Let's do a sort of 2025 clap shot.
Sounds good. Let's start at the top end, the Apple Vision Pro. This is definitely the premium MR experience right now. Strengths, those micro OLED displays are stunning. Eye and hand tracking are incredibly precise. Optic ID for security. And the color pass-through, seeing your real world, it's very, very high fidelity. Really helps blend things. And like we said, Vision OS keeps getting updates, spatial widgets, better personas. Its positioning is clear, though. This is aimed at pros, creators, developers, early adopters, people who want the absolute cutting edge and are willing to pay for it.
Right. And then, arguably, aiming more for the mainstream, you've got the Meta Quest 3 and Quest 3S.
Absolutely. These are the consumer MR workhorses, you could say. They offer good color pass-through MR, solid hand tracking. They run on that capable Snapdragon XR2 Gen 2 chip. And crucially, they have a huge library of games and apps already. That's a massive advantage. What's really interesting now, though, is Meta licensing its operating system Meta Horizon OS to other companies. Like Asus and Lenovo are making headsets using
Oh,
them.
interesting. Like Android for phones?
Yeah. Kind of. It signals Meta wants to build a broad ecosystem, not just sell its own hardware. Makes Quest feel like maybe the Nintendo Switch of spatial computing. Accessible, versatile, lots of content.
Okay, and then for more specialized uses, there's the HoloLens 2. Still around, still important.
Definitely still relevant, but in a very different space. HoloLens 2 is pure augmented reality. It has transparent lenses.
Ah, so you see the real world directly, not through cameras.
Exactly. Digital overlays appear on top of your direct view. It uses hand gestures, voice commands. Its home is really an enterprise. Field service,
Hmm.
remote assistance. Think a mechanic wearing one, getting instructions overlaid onto an engine. Also big in manufacturing, defense, medical training. Very specific high-value use cases. Not really a consumer device at all.
And lastly, we're seeing these lighter things emerge, right? The
Yeah.
smart glasses.
Yeah, a whole different category, more about all-day wearability and utility. You've got the Ray-Ban Meta smart glasses. They look just like regular sunglasses, mostly. But you can take photos, videos, make calls, listen to music, even talk to Meta's AI assistant, all hands-free. Great for creators or just capturing moments easily.
More about quick interactions, less about deep immersion.
Right. And then there are things like the XR Real Air 2 glasses. These are more like wearable monitors. You plug them into your phone or laptop, and they project a huge virtual screen in front of you. Good for privacy on a plane or just getting a bigger display. The newer Ultra version is adding more AR-like features, like understanding the room a bit. So maybe an analogy helps. Vision Pro, the luxury sedan, premium everything. Quest 3, the affordable SUV. Versatile, popular. HoloLens 2, the industrial truck built for work. Smart glasses, the city bike light, convenient for specific tasks. The real takeaway here isn't just the models, it's that the market is segmenting. We're seeing devices tailored for different needs, which is a sign of maturity. Spatial computing isn't just one thing anymore.
Okay, so putting it all together, what does this mean for you, the listener? Where is spatial computing actually showing up day to day? Not just demos, but like real stuff.
Yeah, good question. One really impactful area is healthcare and training. VR surgical training, for example. Companies like Also VR studies show surgeons trained in VR can be faster and more proficient than those using traditional methods alone. And when you add haptics like gloves that give you tactile feedback, from companies like Fundamental VR, it gets even more realistic. You can feel the virtual instruments.
That's incredible, truly life-changing potential there. What about something more everyday, like retail and shopping?
It's already here, often quietly. That view in your room feature. IKEA, Amazon, Wayfair, tons of places use it. Letting you see a 3D model of that sofa or lamp in your actual living room before you hit buy, that's spatial computing on your phone.
Right, I've used that. It's surprisingly useful.
Yeah. And virtual try-on is getting common, too. Eyewear from places like Warby Parker or makeup using L'Oreal's ModiFace tech. You see it on your shelf in real time. Takes a lot of the guesswork out of online shopping. Then think about remote work and field service. Immersive meetings are starting to happen. Microsoft Mesh inside Teams lets people join meetings as avatars in a shared 3D space. It feels more present than just a grid of video faces.
A bit less fatiguing, maybe?
Potentially, yeah. And for field service, remote assist is huge. A technician wearing, say, a HoloLens can stream their view back to an expert anywhere in the world. That expert can then draw annotations, circle apart, point an arrow right onto the technician's real-world view through the glasses. Super powerful for fixing complex machinery. We're even seeing consolidation in this space, companies merging their tools to offer more complete solutions.
Wow, okay, that's a big leap from a standard video call.
Yeah.
What about the folks who make stuff? Creative tools for designers, 3D artists.
Oh, it's becoming a core part of their workflow. Tools like Gravity Sketch let designers literally sketch a car or a product design at full scale, right there in VR. They can walk around it, refine it, even collaborate with others in that same virtual space. Adobe Substance 3D Modeler lets artists sculpt incredibly detailed 3D models using VR controllers, feeling much more like real clay than clicking a mouse. And that OpenUSD standard we mentioned, that's key here. It ensures that complex 3D scene can move smoothly between different tools in their pipeline, keeping everything consistent.
And you mentioned it's even showing up on the regular web now. Web-based spatial.
Yeah, WebXR is the standard that makes AR and VR possible directly in a web browser. This is a really big deal for getting spatial content out there. No need to download an app from a store. You just click a link, and you could be taking a VR tour of a hotel, trying out an AR furniture placement, or playing a simple 3D game. lowers the barrier to entry massively for users and creators.
Okay, let's shift gears slightly. We've seen what it is, where it's used. But how do people actually build these experiences? What's this sort of mental model for creating spatial stuff?
Right, the creation process. At the base level, you have the tool chains and runtimes. Think of game engines like Unity and Unreal Engine as the main creative operating systems for building these interactive 3D worlds. They handle the rendering, physics, interactions. Both support OpenXR, which again helps developers target multiple headsets. Then you have the specific platform tools, the SDKs, software development kits, Apple's Vision OS tools, AirKit, RealityKit, Meta's SDKs for Quest, Google's Air Core. These give developers access to the unique features of each platform, like pass-through video, hand tracking, or those geospatial anchors.
Got it. And the actual digital stuff inside the models, the environments, what are the key content and formats?
The ingredients, yeah. OpenUSD is becoming really central here. Because it's designed for describing entire scenes in a flexible, layered way, it's perfect for complex projects where lots of people are contributing different parts, modeling, animation, lighting. For individual 3D models, you still see formats like GLTF, that's kind of like the JPEG for 3D, designed to be efficient and load fast online. And OBJ is an older, simpler format that's still widely supported.
Beyond the tech, though, making these things feel good to use is crucial. What are some of the design patterns that work, the kind of best practices for usability and comfort? These must have come from a lot of trial and error, right?
Oh, absolutely. Years of it. This is really about the human-computer interaction side. A great example is that eyes select, hands confirm pattern on Vision Pro, gaze to highlight, tiny pinch to click Y. It avoids gorilla arm, that awful fatigue you get from holding your arms outstretched to point or touch things for long periods.
Right. I can see how that would get tiring fast.
Yeah. Anchoring and scale are also fundamental. Digital objects need to feel like they belong in your space. They need to be anchored convincingly to surfaces, thanks, SLAM, and be scaled appropriately. A giant virtual chair just floating randomly looks wrong. Occlusion helps here too. Seeing virtual things hide behind real things sells the illusion. Designers also think a lot about comfort. Breaking experiences into shorter sessions, defining clear safety bubble boundaries in VR so you don't bump into walls, and offering movement options like teleporting or vignetting, where your peripheral vision darkens during movement to reduce motion sickness.
Ah, yeah, motion sickness is a big one for VR.
Huge. And finally, matching lighting and sound is key for realism. Virtual objects should look like they're lit by your actual room lights. And spatial audio making sounds seem like they come from specific locations in 3D space adds immensely to the immersion. These aren't just nice-to-haves, they're becoming essential for good spatial design.
Makes sense. So once creators build these amazing things, how do they actually get them to people? Distribution and monetization.
It's a mix of familiar and new. You've got the dedicated app stores, of course, the Vision OS App Store, the Meta Horizon Store for Quest apps, pretty standard model there. For business tools or specialized applications, direct enterprise licensing is common. Companies buy seats or licenses directly from the software provider. And like we touched on, WebXR is the third route. Experiences delivered directly via a web link. Great for demos, marketing, education, friction-free access.
Okay, this is all incredibly exciting tech, but it definitely brings up some big questions, especially around privacy, safety, and ethics. These devices see and hear a lot.
It's arguably the biggest challenge, and rightly so. Spatial computing devices collect data that's way more personal than your phone or laptop. We're talking biometrics, where your eyes are looking second by second, maybe your heart rate, your facial expressions for avatars. And with Optic ID, even your unique iris pattern. And crucially, they perform detailed room scans. They build 3D maps of your home, your office, potentially capturing very private details about your environment, your possessions, how you live. That data, if misused, could be incredibly revealing.
So how are the big platforms handling this? What are they doing to protect that super sensitive data?
The responsible approach, and what platforms like Apple emphasize, is processing sensitive data on the device whenever possible, like Optic ID data. It stays locked in the device's secure chip, never goes to Apple's servers. Eye tracking data used just for foveated rendering, processed locally, used to adjust the graphics, then discarded. It's not stored or sent anywhere.
So keeping it local is key.
It's a critical design principle for building user trust. Beyond what the platform makers do, independent standards and guidelines are also really important. Organizations like XRSI, the XR Safety Initiative, publish frameworks. They provide best practices for developers on things like minimizing data collection, getting clear user consent, securing data. They encourage thinking about potential harms like, could private info be accidentally revealed in a shared virtual space?
And what about just basic awareness, like knowing if someone nearby wearing smart glasses is recording you?
Yeah, that's fundamental politeness almost. Which is why features like visible recording indicators are non-negotiable. Those Ray-Ban Meta glasses, they have a little LED light that clearly lights up when they're capturing video or photos.
So people around you have a clue.
Exactly. It's about transparency. At the end of the day, trust is everything here. If people feel these devices are creepy or too invasive, they just won't use them, no matter how cool the tech is. Adoption hinges on feeling safe and respected.
Right. And this field isn't standing still for a second, is it? It feels like things are changing constantly. What's happening right now that keeps spatial computing such a hot topic?
Well, one huge factor is just the rapid OS evolution. The software is improving at lightning speed. Vision OS keeps adding features like spatial widgets and better personas. Meta pushes out updates for Quest hand tracking and UI improvements almost constantly. And WebXR, the web standard, is getting more capable all the time, making those browser-based experiences richer.
And we're also seeing this push towards more open ecosystems, right? You mentioned Meta licensing its OS.
Exactly. That's a massive shift. Meta letting companies like Asus and Lenovo build headsets using Horizon OS could really broaden the market, bring in more device types, different price points. Plus, Google is getting serious about Android XR again, partnering with Samsung. Imagine bringing Android's huge app library into spatial computing. That could be transformative. It signals more competition, more choice for users. And underlying all that, standards are solidifying. OpenXR and OpenUSD are becoming mature enough that developers and big studios can really build upon them confidently. Less fragmentation means developers can focus on innovation instead of just porting apps. It lowers barriers, encourages more hardware variety, and ultimately should lead to better, faster experiences for all of us. It feels like the foundations are really setting now.
Okay, this has been fantastic. To really help this all sink in and maybe let you, the listener, get a small taste of these concepts, we've got a few quick things you can try. No headset needed for these.
Yeah, totally. First, to get a feel for world-scale AR. Do a quick search for a Google Arcor geospatial API demo or look up videos of Niantic's outdoor games like Peridot or Pokemon Go. Notice how the digital creatures or objects seem truly locked to a specific spot on a real street or park bench. That helps you understand anchoring content to actual Earth coordinates, not just your floor. Second, to understand that eye plus hand UI, just watch one of Apple's videos demonstrating Vision OS gestures. Try mimicking it yourself, pretend to look at something, then do that tiny little pinch motion with your thumb and index finger. You'll immediately get why it's designed to minimize arm movement and avoid that gorilla arm feeling. Third, experience retail AR on your phone. If you haven't already, grab the IKEA or Amazon app, find a piece of furniture and use the View in your Room feature. Put the 3D model in your space. Pay attention to how it scales, how the lighting tries to match your room, and especially how it gets hidden if you move so a real object is in front of it that's occlusion. Then just imagine that working seamlessly in a headset. And finally, a quick peek into the Creator Pipeline Tour. Go to the official website for OpenUSD, usd.pixar.com. Just skim the overview. You don't need to understand the code, but try to grasp why having a standard, layered way to describe complex 3D scenes is so vital for big teams working together on movies or complex simulations.
Wow, okay. So we've really covered a lot of ground today on spatial computing. We went from, what even is it, to the core tech making it work, where it's popping up in the real world, how people build this stuff, and those crucial ethical questions. Hopefully this deep dive has given you a real shortcut to feeling, well, pretty well informed about this massive shift in computing.
I think so. What's really exciting fundamentally is seeing computing move beyond the flat screen. It's becoming part of our environment, interacting with us in ways that feel much more natural, more human. We're shifting from looking at data to kind of living with it.
And maybe a final thought to leave you with, as spatial computing keeps blurring these lines, weaving digital information right into our physical surroundings, just consider how that fundamental shift interacting not just with a screen, but with our actual environment might eventually change our very perception of reality itself. It's a profound change, and we're really just at the beginning.